I want to talk about what it's going to be like when we hit cost abundance with one of the major necessities right now. What I mean by that is hitting zero marginal cost for either food and water, shelter, clothing, education, or healthcare, and energy and transportation. So one of these seven, and I believe energy is going to be the first one to hit, even though technically education is already there. But since we have this mechanism that's called PhD or doctorate, it's not, because you can't find new knowledge on the internet. That has to be created. But we can get into the nitty gritty there. Everything else is already published online, preschool through master's. So it's free. And we just need to set up the tools to be able to instruct the way we want to instruct, not the way that a centralized entity wants to instruct. But my belief is energy will get there first. And it'll not be global, but I believe it's going to happen in Australia first, where they're not only able to build 100% of their needs, but then build overcapacity and create zero marginal cost abundance for energy in Australia, and then build more overcapacity and then create zero marginal cost abundance for other areas in the world from Australia by connecting underwater transmission. When this happens, there's going to be an unlocking of abundance in Australia, because it's going to be like, okay, now we have zero marginal cost energy. What kind of energy intensive industries exist out there? And then let's start creating those in our country, but let's start creating a blueprint for exporting that too, to the other countries that we're sending zero marginal cost energy to. That's right. And because of the cost intensiveness of the energy previously, most companies would break up the manufacturing process into pieces instead of putting it all into one thing, which again added into labor, added into total costs. So now it's like boom, boom, boom. So that's going to increase efficiency of what already exists, amplify the creation of energy intensive industries moving forward, and all of it's solar, wind, batteries. So there's, with a closed recycling supply loop, zero waste moving into those loops are being created right now, not only for batteries, but for turbines, wind turbines, and solar panels. So just follow this roadmap and tell me if you disagree with it. So we hit zero marginal cost energy first, and then it's like, okay, let's create fresh water, and then it's like, all right, so desalination is very energy. More than 50% of the costs there are for the energy. Boom. And you start that industry from a desalination industry from a base point of zero marginal cost energy. Boom. Those technologies need to evolve to the point where we're either using everything that we're taking out, or that we don't need to take out and we can use it, capture the water vapor or something. I've seen recently that we don't need to desalinate, and we can do it with water vapor. There's lots of different ways to do it. And okay, so now imagine that you have abundant energy and abundant water. What can you do with that? Why don't we start like vertical farming? Because the main inputs there are energy and water. Okay, then it's like, what next? We know that transportation is already starting to go through that curve. So it's like, what if we can get travel miles to look like data plans now? So like unlimited miles for $49.99 a month, that kind of thing. Because we're tapped into this electric autonomous ride hailing service. So it's like that you can get unlimited miles anywhere in the world for the price of a bus pass. So it's like that completely eliminates budget expenditures for public governments and local governments for transit departments. So it's like we have to start thinking about the effects of some of these things. And then that would also, in my opinion, it would eliminate a large portion of police departments, because a lot of them create their revenue through giving tickets. We have to figure out what's going to be the solution to that. All right, so energy, water, food, transportation, all of these things are contingent upon zero marginal cost energy to being zero marginal cost the rest, which makes you think. You can theoretically create an open source version of everything that's decentralized, whether it's a product or a service. And it all has to go through a process. that'll get it to that decentralization. If you try to start decentralized, you're going to go through the same process to get to the decentralization phase, because you're just a decentralized blockchain and blockchain itself, and it's not quite to disruptive growth yet because of the gateway mechanisms involved in blockchain. It's not seamless yet. You need to approve transactions. You can set it up to do all these things automatically and have sensor-driven data, meaning you don't need humans at all to verify entire supply chains now. That exists. That's existed for a while. Why don't more people do it? I don't know. Maybe the learning curve. So if we can eliminate a learning curve needed for using blockchain, I think that's when we'll hit disruptive growth and make it as seamless as using the apps that you use now. Most of the blockchain apps require you to learn crypto, send crypto into the app, and then learn how to disperse it through the app. So a lot of people just don't want to do that. Okay, so let's continue. Let's continue this. So now we have energy, food and water, transportation. So let's say, okay, now what about 3D printing? 3D printing is major energy intensive and material intense. So what kind of materials are used in 3D printing? All different kinds. Like there was a 5-year period in the 2010s where massive evolution was taking place in the 3D printing space by Hewlett Packard, and nobody was paying attention to it. And like they invented nozzles and materials for almost any kind of material going through a 3D printer. And it's like, and now this is almost a decade old. So we have to realize that the limitations are there, yes, because we're not down to the sub-micron level yet in 3D printing technology. But when that occurs, we're going to be able to manufacture at the atomic level automatically with 3D printers. And well, it would probably be something else at that point. We might call it like a 90 printer or something. There's a large argument for glucose from hemp making up the majority of the input for these things. And then you mix it with small amounts of other things to be able to get to what you want. So and then we've already gone through the Hemp Act, the Agricultural Act that industrialized hemp. And that was 5-6 years ago. Being able to take the fibers from hemp, which we know to be one of the stronger fibers out there, and not only create calories with it, but materials that are very, very strong. And I already know that from my time in the legislature, some aeronautic manufacturers are 3D printing with hemp glucose to make their jet parts stronger. So this is old stuff. So hemp, I believe, can be the key to reducing material costs for everything down to pennies on the ton kind of thing. Pennies on the pound to begin, but pennies on the ton. So that's a zero marginal cost effect to print new physical things. Now, printing homes is another piece of this. That already exists too. And there's all different kinds of mechanisms. You can build modular pieces, 3D printed in a facility, and then take it to a place and build it. You can put cement down in a certain pattern, and then you create the structure and then you build around it. But I believe at a certain point with this material base, it could be hemp or whatever, you're going to be able to 3D print entire homes with different materials in different spots. You're going to be able to print siding, nail, everything in one go. So everything you need. And I don't know how that would work, but I know that's being worked on to be able to switch to different material in the same